Cool. Well, welcome back, everybody, to our series where we are going through the book Building Ontologies with Basic Formal Ontology by Andrew Spear, Barry Smith, and Robert Arp. And again, I'm Ian. I'm a graduate student at the University of Buffalo in the Masters of Applied Ontology program. Obi.
Hi guys, welcome back. You already know me, we're just gonna dive right in. Today we've talked about in our earlier chapter, we talked about one and two, what is an ontology, what is a taxonomy. We are now working with the principles, right? We have um looking at the best practice principles for like a domain ontology design, which includes several parts, right? And we have like realism, we have adequatism, we have reuse, we have guidance, right? And the scope of like relevancy, the granularity of what you're trying to do, handles things that doesn't exist, right? So today we're going to explore the world of those principles and see how they help us building ontologies. Ian.
Cool. Yeah, thanks, Obi. Yeah, so I'm just going to pull a quote right out of the book here, which is kind of going to summarize the last chapter, and then I think hopefully get us into talking about these eight principles that Obi was talking about. It says here, the problem of designing an ontology is the problem of designing a formalized representational artifact, including a taxonomic hierarchy as backbone, whose representations designate universals, define classes, and the relations between them. And so the question is, how do we do this? And there are eight principles to do it, as according to the book. So let's jump in. The first one is realism. And this means that reality exists separate from our perceptions of the world. So this is asserting that through scientific inquiry, we can know the features of reality, including universals and the relationships between them. So in this case, and we talked about this in the last episode too, but BFO is a realist ontology, and so we model reality. We don't model concepts. We don't model the data um, that the system is about. We model the thing that it's about. Um, And then number two is perspectivalism, which is the recognition that reality is too complex to fit into one scientific theory. So there's a bunch of different scientific theories. There's a bunch of different lenses that every discipline is going to look at the world through. And so, for example, we might be looking at something through a molecular biological lens. We might be looking at something through a physics lens. We might be looking at something through a social science lens. And those are all going to have different like levels that we're going to be looking at things. And so all of those perspectives are valid and they all need to be modeled. But it's going to imply that ontology builders should not try to represent reality, all of reality in one ontology, but use a modular approach to modeling. And then number three is fallibilism. And I really love this one. It states that we might be wrong about our current understanding of a domain. So that means that the ontology, because reality exists separate from our understanding of the world, we're going to sometimes get it wrong. And so as we learn more about reality, which is what science is doing, we need to make sure that our model is going to be able to be updated in the future. So we recognize that we might be wrong about something that we're modeling right now, based on the scientific understanding of that domain. And in the future, we need to be able to change it. And then also, as we learn and make changes, we should track the changes in our ontology as we make those changes. And then the fourth one is adequatism. And so this is an opposition to reductionism. And reductionism is the belief that philosophy should be boiling complex things down into simpler and simpler parts. So the flip side of that is going to be adequatism. And from an adequatist perspective, just because we can describe, let's say, for example, like a forest at the molecular or like at the atomic level, that might not be the best or the only valid description. So, for example, reductionists, they might say, well, like ultimately diseases are just molecular malfunctions. So let's describe everything at the molecular level. And an adequatist would say, no, we also have patients, we have symptoms, we have organs, we have cells, we have molecules. They're all real and they all need representation. And so the ontology should capture how they relate across levels rather than collapsing everything into one thing. Yeah, and then number five, Opie, do you want to take that?
Yes, thank you, Ian, for telling us about the Big Four. And as you can see, the Big Four is really, really useful. We'll now go back to like the practical design principles, where we have the Big Four. When you come to the practical side of things, we have like things like the principle of reuse. The principle of reuse is telling me, don't rebuild the wheel. We already did. We have an ontology that already exists for a wheel. Use the ontology. If there's a unique case that you need that we are not covering in the ontology, reuse it and then extend the ontology so that way someday tomorrow someone that needs meets that particular requirement that you're building today can adapt what you're doing. Because when we reuse components, we survive the scrutinies, right? We find it easier to integrate with others and we don't go on building silos ontology. And I think that is really useful. I think this correlates with like reusing software engineering, use reuse in factories because when you have the follow the principle of reuse, it makes everybody follow a guiding step instead of everybody doing their own unique thing. We all know if I was to talk about DNA, Ian knows what I'm talking about, a doctor knows what I'm talking about. Somebody that doesn't know the intricate details of a DNA understand what I'm talking about because we're using the same language, and that language helps us communicate across the board. We have to also, this is the tricky part, balance utility with realism. And I think that this is where a lot of people struggle, right? There's a sweet spot where we have had enough consistencies and usefulness enough to ship, right? You don't have to have it um too pure that nobody can use it, and you don't have to have it too pragmatic that it turn into a sloppy tag list, right? So you have to balance that, and that balance is a very careful balance that BFO helps us to do, because it makes the over loose enough that you can use it, and I like that because when you have that sweet spot, you don't have to like say, oh, I have to get to this place to like be able to use ontology. And I think the last one will be the process of open-ended. This is just basically for me, that's an engineer looks to be like a DevOps concept, which is basically a DevOps semantic where the ontology design is open-ended. It's open-ended for a lot of reasons. It means somebody can come over tomorrow and use it, refine it. It's not finished. So I can use something to the point where I need it, but somebody can look at it tomorrow and say, hey, I need this and more, and be able to like pull more ontologies together to be able to do it, use it to do what they need. And I think this helps us build better ontology, makes us not have silos ontology, and makes us be able to like collaborate and have a huge effort towards BFO. And I think the one I loved, I actually love this, is the low-hanging fruit. It's like you start with a stable, obvious core of your domain, and then that everybody agrees today. So we all agree like a unicorn is something. But if I was to build, I can't build a unicorn ontology, right? But I can, it's not in the real world. We know it, we know about it, but it doesn't exist. So we can do things that everybody agrees on before modeling the edge cases that create endless debates, right? So we take care of the ones where we all agree, and then we fight about words like geopolitical regions, and then dissect it because those are places where edge cases that have to be smoothed so everybody understand what it means and are in sync, I would say. Ian.
Yeah, cool. Thanks, Obi.
Mm.
Um, yeah, I think I would just add two things to that. One of them is for the principle of reuse, there is the OBO Foundry. So I'm just going to plug that. I'll also put a link to that in the bottom in the show notes as well, because that is a place to find a lot of BFO conformant ontologies that you can adapt to your own needs. And then that's going to be built onto that same hub and spoke model that we're talking about, and increase the interoperability. So then the second part of the chapter is talking about there's like a specific outline of steps to be followed in designing a domain ontology. Demarcate the subject matter of the ontology. So in that case, we're defining the scope. What's in scope, what's out of scope. What are we modeling? Are we modeling the whole world? I hope not. Um, yeah.
I think yeah is where realism actually works a lot, right? You want to model what exists, what everybody understand to be the core, and have that flushed out, and then have that build the ontology and be able to like start from where we both agree on, and then we could flush out the edge cases later, but using one of the already trusted ontologies to start that process.
Hmm. Yeah. Yeah. And like if we're making a thing about insects, we're gonna not include spiders, for example. So just like, we're saying like what's in scope and what's out of scope.
Yes.
And
So,
then number two is gather information,
okay.
identify the general terms in existing ontologies and in standard textbooks, analyze to remove redundancies.
This is a fabulous one. The one problem that I see this solving is when you remove redundancy, we all speak differently, right? We had this example when we started in our previous video where we said we have different generations, they speak differently, but the vocab means the same thing. So now you can like have words that means the same thing, but used differently in your ontology to mean the same thing. So we don't talk past each other, which was the purpose of why we have ontology.
Yeah. Yeah, and I mean textbooks. I think this is a really wise idea is to like gather terminology from something that's like very well established. And so if the domain
Sure.
that we're talking about like has a textbook for it, that's a really good domain to be modeling, for example, because someone has spent the time to like there's a glossary in the back of that book, and we can pull a lot of the terminology from there. And then there might be a bunch of redundancy in the terminology that we've collected, but now we have like a list of things that we're going
Yeah.
to be modeling. And that's a really helpful step. Number three then is order these terms in a hierarchy of the more and less general ones. So here's where we take
Yes.
all the terminology that we collected, and now we're gonna start to organize it into like is a parent-child relations in our taxonomy.
Yes. This is the part where taxonomy hierarchy is does the ontology and identify like um the nodes of your ontology, right? So it basically would help you out sorting out the hierarchy. We can refer back to chapter two where we had the structure that you posted. And you can see that hierarchy was created based on rule number three.
Okay, and then number four, regiment the result in order to ensure, and there's three parts here. So A, logical, philosophical, and scientific coherence.
Uh-huh.
B, coherence and compatibility with neighboring ontologies, and C, human understandability, especially through the formulation of human readable definitions. So this is step five is when we start to, model it in an OWL or something like that, like a
Yes.
computable framework. Largely, we're defining the terms and we're making sure that all of this stuff, excuse me, is philosophically and scientifically coherent so that everything makes sense. Is this really how reality is? We can look at it and ask that
So
question.
I think that is a great one. Like, we have the reference on the high level ontology that serves as the root node, but defines the gathering of further information, right? So when you look at how that is built out, you now kind of see that consistency, right? You see how I know the book talked about how the succession generation at one point where like you can see the mapping itself. So I think that hierarchy is going to be very key. And there's an example that's given. I know there's a research that I read 2 semesters ago where they pointed how this was very significant in the medical ontology. It helped them a lot.
I will say this to me seems like the most difficult part of this whole process. I'm going to go ahead and say it like, the first step is we're saying like, what do we want the ontology to be about? The second one is we're
Yes,
gathering a bunch of information. So like we're talking to subject matter experts, we're looking for textbooks, we're looking for literature about the topic that we're talking about. Number three is we start to put it in a hierarchy. So like
number
which
four
which
is
might be
gonna
difficult. You could certainly be arguing, like you get five people together, like how do you actually put this into a hierarchy? But I feel like number four is the thing that like and again, like we're going to focus on the low-hanging fruit first, but there are certainly going to be things that I would think, when you start to, especially if you're working on a team,
yes.
which we often are, this might be the crux of the situation here.
Yeah, and I think number four is where things become the road meets your slabs meets the concrete because now you start defining term, right? You define what, say, every word that you put into your ontology must have a definition, right? So when you define it, you have to have the definition for it. So you can use that because if each word you put in has a definition, it might be different from what somebody else is calling it in their ontology. But when we look at the meaning of each word, if they are referencing the same thing, then we can do that linkage in our ontology.
And then number five is formalize the regimented representational artifact in a computer usable language in such a way that the result can be implemented in some computable framework. Oh.
Yes, this is OWL, and you could do it you could do it in RODF, you could do it OWL, you could do it in Todo.
Mhm.
You could do it XML, I believe. But I would say industry standard today is Protege.
Mhm.
Protege have all the reasoners and you can import it and you can build the ontology in Protege. But as you build the ontology, you see the beauty of ontology one. The other part of it is if you model your ontology well, following these principles, you will be able to scale it at large. It'll be easier for you to scale it. But if you don't follow the principles, like if you, we can add the pizza ontology tutorial to this particular video because that shows you how to build, uh, use Protege and use the reasoners. It explains why you would have a pepperoni pizza. When you order, it gives you a pepperoni pizza of what you requested instead of getting you an all meat pizza after you're done. Like those reasons come into effect. You were able to build it out using and export the file as an hour or whatever format that you want. Around this up there, like there are a few things that I would say you should do to be able to like is um write down like your competency questions like when you said get requirement earlier from the big four, get your competency questions in. The earlier you do that, the more you can limit your scope, right? You can limit the scope. You can use BFO principle of reuse to like help you do that. You never start from scratch. You would go in and get all this ontology, search for existing repos that have the validated ontology that's already mapped to your domain and then use that as a start, right? Don't just say there's no ontology for me. There's an ontology in your industry that will give you the help to show you how things are done. And I think that like always one of the other thing I would say is brainstorm like a comprehensive list of the terms. You don't have to have everything, but have a comprehensive list of the terms you need, the entity, the concept that are relevant to your domain, because that like sets your stage for first building that vocabulary where you can now have those definitions. Because when you build the ontology with no proper definitions, you run into a lot of problems. And I would say the last part that I will touch on as we end this is that you should define your class and hierarchy, which is taxonomy, very strictly. Like, is a relationship like a dog is a mammal, a mammal is a vertebrate. So we have those relationships. Just choose a very top level ontology. And I always recommend BFO because BFO has a lovely upper ontology, but you could use any standard ontology and be able to exploit and enjoy. Ian,
Next time we'll be back with chapter 4, where we'll continue talking about terminology and hierarchy and classification.
thanks, guys.
Yeah, thanks.